So we're going to implement an ArrayList, vec, din array, same thing in Rust today. Let's go ahead and read through the little article we wrote about it, and then we shall actually write the code. What's up, Amit and Nightshade? Hey, Shreyas. What? You didn't follow me? I swear you. I thought we just had this conversation like not a long time ago. I don't know. It's fine. It's fine. You probably unfollowed me. I probably offended you and you unfollowed me. It sounds, that's my assumption. What's up, Shreyas? And Nightshade. Yeah, you were slow today, Nightshade. I don't know what you're doing. You're just sleeping over there. Is Prime still streaming? Is that what it is? Okay. Of course, I started the recording, and this is what happens. No, it's all good. Amit, you kill me every time with that. In most modern programming languages, there is a sequential data structure with a dynamic length and arbitrary data. In a statically typed language, that data typically has to be of a single type. In Rust, this data structure is called vec. In Java, it's called an ArrayList. In JavaScript, I just said it, it's called an array because JS doesn't care. Since vec vector can mean different things in different languages, I will use the term ArrayList in this article. Really? Arrow down doesn't work? Oh, I just wasn't actually focused on the right window. Nope, arrow down just magic. It just doesn't work at some point. Imagine having a scroll bar where arrow down doesn't work. Okay, it's all good. We'll survive. Raw vec foundation. There are two important parts to understanding and implementing an array list: the contiguous memory buffer and dynamic size. We've already handled implementing a growable contiguous memory buffer to base our array list on that we called raw vec, copying the Rust stdlib. So now that we have that buffer, what does that provide us? The first thing it provides is a pointer to the first t size block of data and the capacity size of the buffer. This allows us to use pointer math in Rust to reach every block of data in constant time. This is why array-based data structures have constant time O1 reads. To get to any pointer in the array list, all we have to do is add the offset, aka index, to the first pointer that we have stored in the raw vec. The second thing raw vec provides is growing the memory buffer allocation per our request. If you want to read more about the cost of resizing and how resizing works, I recommend going back to that post. Hopefully this helps explain why we started with raw vec. We've talked about constant time reads. What about add and delete? In Rust and the implementation below, these methods are called push and pop. As you can read in the stdlib documentation for vec pop push, both of these operations occur at the end of the vec. To push a new element to an array list, we find the next available block in our buffer raw vec, which is simply pointer plus ArrayList.len, and write our new element at that block. Adding to the back of an array list is thus O1 constant time. Technically on resizing, this isn't true, which is why we say it is amortized constant time. To pop an element from an array list, we calculate the offset of the last element that has been added, which is simply pointer plus ArrayList.len minus 1, and return the data in that block. Again, we just dealt with constants, so deleting popping from the back is also O1 constant time. So what if we wanted to add or delete at an arbitrary index? We no longer have our constant time guarantees because we have to move, mem-move in C or std pointer copy in Rust, any data after that index to make sure that our array list still has valid data at every point. Thus, adding deleting at an arbitrary index is O(n) linear time. Linear search on an array list is unsurprisingly O(n) linear time. It's the same time complexity as linked list. But because of cache locality, linear search is typically faster on ArrayList. Here's a simple implementation of ArrayList with push, pop, and an index trait impl for get by index. Thought I was going to sneeze. Let's see. There it is. There it is. Space generally scrolls down. Let's see if that works on this. Oh no, because I'm in an editing window. so it just makes edits. It's fine. If I wasn't in editor mode, maybe it wouldn't matter. All right, so we're going to impl that array list now. Little summary is there for your reading pleasure. And we'll probably publish that post once we're done. So let's get started writing some code. Let's see, we're here. This looks fine. Do we have a clean slate? We do. Let's just touch source ArrayList rs. And we'll start in our lib. Add ArrayList. And we should be good to go. Copy the allow dead code because no matter what, I just can't remember that for some reason. Hey, Dylan. Thanks, man. You can actually watch today? Wow, that is rare. Ever since the Triangle Corp swallowed you up, I feel like your afternoons have been busy. But yeah, it's fun watching you do Rust. You're doing a good job, Dylan. You're doing a good job. Not like you need me to tell you that. Okay, so let's figure this out. Yeah, you're welcome, champ. What do we want to put on our array list? We're going to have pop. We're going to have push. We're going to have new, of course. And then we're going to impl index. Okay, so let's start with our main thing here, which is our array list struct. Our buff is going to be our raw vec. And both of those will have generic parameter of t. And then we're going to have a len, which we'll just call useSize. I don't think there's anything else we need. We have our buff, we have our len. It's going to be pretty simple. Okay, so then we're going to impl t array list t. And the first thing is we have our function new, which is going to return self. Yeah, since I'm using a raw vec holds the capacity. So raw vec's just taking care of that logic for us. Yeah, no worries. It's a good call out though. Okay. So new self, pretty simple. It's just going to be array list, and we're going to say raw buff is raw vec new, and len is 0. You were in C land. Happens. Okay, so we need to actually import raw vec, so that is just going to be a use crate raw vec. Is that not how you do it? Oh, a similar name exists in the module raw vec. Right. I forgot. There we go. Yeah, and then I have all that marked as private, which I knew I was going to get into that issue. So let's say, whoops, that's not what I meant to do. We need to pub these things. So we need new to be pub. And what else do we want pub? Just new and grow, basically. Okay. That should take care of those errors. Looking good. We have a raw vec new. and we're so happy. Let's go ahead and write this real quick. The config test, I want to say. I always forget these. It's just test, no config. Function. Functions describe the world. Okay, ArrayList works. And if we have a list of I always get this backwards, don't I? It's ArrayList. I can do this. No, it is. I'm right. Let's just do U8s. We'll just make it nice and simple. ArrayList U8 new. I think that should do it. I did it backwards, didn't I? No, it's just this. There it is. Okay. Just forgot the arrows. Not crazy, right? Like that's what yeah, okay. We're good. Hey, what's up, F Collector? Buff len cap is 90% of your C structs. Funny. That's fair. Okay, so this looks fine. Let's just do a little assert eq on len. That should be 0. And that should get us started. We'll do a cargo test ArrayList. Looking good. We can construct a struct. How about it? All right, so let's start with adding a value. So we're going to push a t onto it. So we'll just call that a val. Oh yeah, we might need the actual list in our push. That might help. And we'll just return a unit from push, aka nothing. And how does one push? That's the question. I kind of wonder how stdlib does this, but we won't look yet. We'll just start with our own little thing. Yeah, the raw vec is handling that for us. So it's like rusty that, I mean, granted, I don't have a width capacity on the vec or raw vec, so we are just initiating with a non-null dangling pointer and a capacity of 0. And then on initial capacity, we're growing it to 5 when we first push a new item. So this part might feel a little weird. We're gonna see how this goes. First, we have to make sure we have enough capacity for this item, right? So we're going to check is self.len. So if self.len equals cap, right? I think that's the right thought there. Equals self.buff.cap. I'm guessing I have to make cap pub as well, right? Or I have to add a little function here. What do I want to do? Do I want to do a cap method? I think we'll just do a cap method. That's fine. It's kind of like a Java getter at the end of the day. That's a little bit scary, but it's okay. Yeah. Let's see how this goes. Field cap. Oh yeah, because I still didn't actually make it. Okay, this is fine. I don't need parens. What am I writing? JavaScript? I don't need parens in this language. Are you kidding me? Why isn't this working? There we go. Okay, if self.len equals self.buff.cap, and what are they saying? Okay, we just don't have a block. Yeah, we haven't actually written the code. Right, then we want to say self.buff.grow. Okay. This is fine. If it has enough capacity, we don't have to do anything. And now we actually want to write our value to that pointer. So this is like a little bit weird because I kind of wonder if I want to actually just implement write on my raw vec. Huh. Let me think about this. I probably do. I'm probably just going to want to write. So maybe I do want like a push on my raw vec. But I don't actually want to push. The thing is, I want to use my raw vec for this, and I'm also going to use it for my ring buffer. I don't want push to actually grow. I kind of want more control over that. But maybe I'm just trying to abstract too much. It's going to be a little bit ugly, but it doesn't matter. We'll just go with this, and we might put it onto raw vec later. We'll just write it here for now. So yeah. So then we have to get the actual pointer and do our pointer math, right? So let's just say let pointer equals self.buff.pointer, I believe is what I called it. And that is our little non-null. And again, let's just make pointer pub for now, so I don't have to keep putting things that I don't really need for now. Well, let's just do this. And then what I want is pointer.add. I think I have to cast this to a raw pointer first, though, in order to do an add. Yeah. I am right. Oh yeah, I have code for this already actually in raw vec, because I kind of did this already in a test. So because we are what we are, we're going to actually just copy this code real quick. I mean, we wrote it during this series. It's not really changing anything, right? Okay, so we have our pointer. Let's forget about that. Let's just say pointer.asPointer.add, and if I remember right, asPointer is actually unsafe, or is it just add that's unsafe? It's just add that's unsafe. Okay. So we could do the as pointer up here and already have our mutable, I mean our raw pointer, and then we have pointer.add, and this is where we need our actual place where this is going. So the offset is our current length, right? Because we haven't incremented length. So pointer.add is our vec len, ArrayList len, same thing. And then we have std pointer right. Gotta love hard code there. And this should just be val. And let's delete that and see what we did wrong. Nothing so far. Okay, so what did we do? We have our non-null pointer, which is like a special helpful thing that kind of like provides some safeguards, having the whole non-null pointer. You can read the docs on that if you actually care. Won't go over that today. We cast it to a raw pointer. We do our really hard pointer arithmetic to get to the right place we want to add this new item. And then we actually write the data into memory with std pointer write. And really, we should put those up here. We should just say use std pointer. I'm probably going to just keep it as pointer and then use it like this. I like that. Pointer right, p val. Looks good. Okay, so then vec, like the raw vec's already handling our capacity updates. So I think all we have to do is increment our length. So we'll just say self.len plus equals 1. Did we do everything we were supposed to do? I think so. I think we did everything we were supposed to do. I could, of course, like not have this and just this would be a really long line. It would be that whole thing. I don't know. I mean, it's a little less lines of code. Because the article, like I like having less lines of code, I might just leave it at this. But I'm also thinking, in reality, if I was really going to go ahead with this interface, I'd probably just have a little method on ArrayList to get that pointer, like that returns the raw pointer. And then we don't have to do this a bunch of times. I don't know. Maybe that's just nice anyway. Probably is. Maybe we'll actually make some things public this time from the get-go. Okay. Sure. So there's push. We'll worry about that later. Let's do pop, and then we'll just test them at the same time. So pop takes a mutable self and does not have an underscore dot, but returns a t. And what do we want to do? We have to read. We have to do an unsafe read on that. Okay. It's an option t. That might help. If self.len is greater than 0, this, else none. Okay, so what do we want to do here? We want to get our little guy, right? So we want to say self.buff.pointer.asPointer.add self.len -1. That should be our P. Yep, looks good. And then we want to say let v equals, it'd be pointer, I think it's just pointer read if I remember right. Yep, pointer read P, and that actually already returns our T. So we can just, I couldn't remember if there was like a result or something in there on pointer read. So if we just go here, delete our semi, That should be pop. Okay. So these are good. So let's do our self.len minus equals 1 here. And we're not worrying about shrinking the raw vec. This is so hard, guys. This is so hard. All right. Let's, now that I said that, let's see if it actually works. Still day drinking. It's a pineapple. It's a pineapple spindrift. Okay. At least that's what I tell people. Let's see. We have a U8. Let's push a 5 on there. And we're going to say assert eq l.len1. And then we're going to say assert eq error in process filter args out of range 69. We know that's what we want, right? Just kidding. That's when Emacs decides to freeze on me. And I still don't know. It's probably some package that's screwing everything up. But I just open a new frame and I'm good to go. So then we're gonna say l.pop, and this should be 5. And this isn't gonna work for a couple reasons. First is that this has to be marked as mute. And why do you hate me? Mismatch time. Oh yeah. Sum 5. Which reminds me, the other test is on an empty list. L.pop should return none. Looks good. Okay. Let's try this test. Let's see if we did it right. No, we did not do it right. All right, what failed? Attempt to subtract with overflow. Nice. All right. Nice. Almost died there. Almost died with that drink. We're okay now. I think I'm gonna make it. Oh, if only this worked. Okay, so we panicked at line 45. Okay, yep, not surprised. If self.len is greater than 0, okay. I mean, why is this run? Oh, right here. I already decremented the len. Classic off by 1. It actually makes the code nicer though, because then I can just pass self.len. If only I died. I'd rather die than fail a test. Let's go. Let's go. All right, first try-ish. Pretty close to first try. Dude, this is some very chill music, which I kind of appreciate, but is maybe a little too chill. All right. Let's see. This is fine. Let's just try pushing 5 more elements. Make sure our raw vec doesn't blow up. You know what I mean? We can go up to 255 on a U8. There we go. Yeah, we're getting creative now. Okay, this looks good. And let me just make sure we don't get any panics out of it at least. That's nice. It's nice we didn't get any panics. And we should have a len of 6 And I mean, we could go through, we could do a bunch of pops until we get all the way to the bottom, just to make sure we didn't like really screw something up. Let's see. Oh wait, no, this is 5. This is 5. So that means I need to push one more element because I already popped one off. Let's do a 6. Okay, so now we have 1, 2, 3, 4, 5, 6, and we have 10, 2, 54, 7, 8, 9, nope, 6. I'm implementing a data structure in Rust. Yeah, we're implementing ArrayList, which is essentially Vec. I mean, we're not doing the full thing. All right, what did we get wrong? Oh, I just did it backwards. It pops from the back. That's perfect. Okay, this is a lot of fun. Fuck. Okay. Duh. One of those things that I just wasn't thinking hard about when I wrote this test a second ago. Okay. That should be right. There we go. Just in time for the test and the failure. What's funny is I think my tests fail most of the time because I write the test wrong. It's not even, I don't know. You're around here quite a bit, Purplish. I think it's probably the majority of the time that it's just I wrote the test wrong instead of I wrote the code wrong. If I just didn't test, there'd be less bugs, right? Okay, pretty cool. We did that in, I don't know, 20 minutes. New push pop, not bad. Let's go ahead and impl index. So we are going to, let's see if I remember how to do this. Impl index. Wait, we need a little T. We need a little T action here. Impl index for ArrayList T. And if you're still there, Dylan, this is what I was trying to tell you before. One of the nice things about the LSP is when you go into this impl index block. Oh, now it's not gonna do it. Now you're not gonna do it. This usually works. This is probably just Emacs. Let's be real. Unbelievable. Maybe I just wrote it wrong. I could have written it wrong. That's classic me. Let's look at index. I can't remember how it works right now. Oh, that's right. I have to give it an index. I have to give it an index type. That's why it's not working. So we have to give it a usize here, because you can implement the index trait for different index types. Yeah. I am indeed in evil mode. Okay, here we go. What I was trying to say. Let's see if it works this time. Nope, it still didn't work. Okay, never mind. So is it not? Why is it not working? This usually works. Oh well. Maybe this will work. Nope, no match. Okay, I'm just totally screwed right now. Let's see. Right, impl index nucleotide for nucleotide count, type output equals usize. Sure. I forget what type output actually means in an index implementation. So usually if I go in, we can do this real quick. This is what I'm trying to illustrate. Like if I wanted to impl my own debug, format debug for ArrayList T. First of all, I would need this. Let's see if it actually works. There it is. it does this for you. It gives you the whole thing that you need to implement for debug. Once you actually write out what trait you're trying to implement, it does the rest for you. Really nice. But for some reason, that's not working for index right now. It's probably a me problem. Probably a me problem. Okay, I forget what output actually means in the index trait. The returned type after indexing. Oh, okay, so output is just T. Okay. So we just add our, maybe that's why. Maybe I have to do this. And then it will work. Yeah, and that's what it's doing. Emacs is just doing it for me. It's calling that code action. But I don't know how to call code like maybe there's like a code action different keybind in NeoVim. I don't know. I don't use NeoVim. Okay, let's see if it will give me my little function index now that I put that. It still doesn't. Okay, it's fine. I use eglot. I tried LSP mode and it just did not work very well for me on my system. Okay, type output T. Yeah, it's not a trait. You're right. Okay. What am I missing here? Index nucleotide for type output equals usize? Am I thinking, no, this is right. Yeah, see, they're using nucleotide to index into nucleotide count. And then it's outputting a usize. So it should output a T. It actually should output a ref T. Expected trait found type parameter T. Okay. I haven't done this in a while. Obviously, I'm just forgetting something. So this is saying type output not sized. Performs the indexing operation. May panic if the index is out of bounds. Right. Okay. I don't know what I did wrong here. So it's expecting a trait for the output. Should I just, I mean, I can do this, but I'm pretty sure that's incorrect. I don't know why you would expect a trait here. Oh, I'm being dumb. That's the definition of, oh my God. Michael. I was just being dumb. You just new type it. And I think actually I do not put the ref. Yeah, because they have it as self output on function index. Okay. So let's see now. Now, is this going to do what I want it to do, or do I just have to type this out like a freaking pleb? It still doesn't want to do it. That's really annoying. I don't know. It must be just something wrong, broken in Rust Analyzer for this one trait. Okay. Index is usize. And this returns and so I can say anti or I can say and self output. I'm just going to say anti. Okay. So basically here it actually panics, which is annoying if you're out of bounds. So if you say if index is greater, I guess we'd say greater than or equal to self.len. But it's not self.len, is it? Yeah, it is self.len. Just kidding. If index is greater than or equal to self.len, then we're going to panic. And I can't remember index out of bounds. Sure. That's fine. Otherwise, we have to use unsafe. And we're going to say, we're going to do a read basically. Let me just think about this. Is there another way of doing this without unsafe? I don't think so, because we're using pointer math to get there. Yeah, nope. So it's going to be very similar to pop, except we don't have to add self.len. And then here we would actually do like a pointer read and then a ref. So this is pointer read p. Maybe as ref will work. It might not. I can't remember. I guess it depends on that, but it's still hung up on this index thing. Oh, that's why. That's probably why Rust Analyzer didn't work. It's because it didn't know which index I was talking about. That's funny. Okay. It was a me problem. Aren't we so surprised? Use stud ops index. That's probably why it didn't work. Yep. I'm pretty darn sure. Do I not need that because... Oh, no, it's just because asref is not in there. Okay. So in this case, I can do a lifetime annotation, I think. I think they'll let me do that here. But it might just know that it's coming from self, and I might not need the lifetime annotation. We'll try this. I don't know if it's going to work. I kind of don't think it is. I can't remember how to do this part. Temporary value created here returns a reference to data owned by the current function. Yeah, I already know that. How do I want to do this? So I have a T. I mean, I could add an asref, but I don't think that that's the right way to do this. Let's see how they did it here. They don't have to use unsafe, first of all. And they didn't have to use... I'm forgetting how this part works. I guess we could try it lifetime. Real fire, absolutely. We could try a lifetime annotation, but I'm pretty sure it's going to reject it. Yeah, it's a TV for sure. Yeah. It's not happy with my lifetime annotation. Well, first of all, I did it wrong, I think, anyway. It's actually that I need to put the lifetime annotation on this. Does that work? No, it still doesn't work. Cannot return reference to temporary value. I promise it still exists. I don't remember how to fix this. So Okay. Well, this is my skill issue for the day. So that's good. I mean, it wouldn't be fun if I just did all of this without any issue. Yeah, that's a label, not an annotation, right? Yeah, well, no, I mean, it's a lifetime label, sure. But it's like in Rust, the only time that that's valid is for lifetimes. Like there's not, those aren't like general purpose labels, but maybe I don't know what you mean by that. Shandu. Okay. Maybe T as ref is correct. We could just say, actually, this has to have as ref on it. And then we can say as ref here. Okay. Maybe this will work. Missing generics for a trait as ref. It's as ref T. Nope. Cannot return value referencing temporary value. It's still the same fucking thing. All right. Oh, fuck. How am I supposed to fix this? Maybe there's a better thing than stud pointer. Is there a better thing than read? I don't think so. Reads the value from source without moving it. This leaves the memory and source unchanged. Sure. Oh, you know what I think no, I didn't do that. I don't think I did that last time. I'm trying to think. How did I fix this in the past? Huh. Recreates a bitwise copy of T regardless of whether T is copy. So how do I return a reference to something that I technically have ownership of? Because I know that it should still exist. I don't actually know. I mean, I could push it to the heap, but that's stupid. That doesn't make sense. Like, that would be a dumb way to do this. I really don't remember how to do this. Okay. I guess we'll just have to work on some Google stuff. I guess we could ask Jippity. Yeah. I mean, I've done it before too. I literally don't remember how. Okay, I have to log in. Hold on a second. I don't pay for Jippity, so we'll see just how good it gets. I forget how to do this one. If I feel like if it wasn't this weird unsafe stuff, like everything would just be working with the normal ownership model, so I wouldn't have to think about it. But I could be wrong. You never know. Yeah. Okay, this one. There we go. And what do we have here? We want to ask, how do I read a raw pointer from read a raw pointer in Rust and return a reference to it? Can you use a lifetime generic and stick it on the return? That's what I tried doing. So I tried adding a lifetime annotation and it didn't actually work the way that I thought it was supposed to. Holy shit, this is a lot of text, Mr. GPT. Yeah. Yeah, it's a good instinct. I think that would have potentially worked if we weren't doing weird memory, like reading raw memory, basically. Unsafe. Dereference the raw pointer to get a reference. This actually might be the way to do it. Okay. So I have a pointer. Oh, I can just, no, let me think. So I have this. Okay, let's just try commenting out this line real quick. Yeah, exactly. Yeah, that's what I just tried. Like basically that exact thing. So what happens if I just say star p? So let's just say let p equal star p. That gives me a t, but I think we're just right back to where we were before, right? And it doesn't like this. It hates this. Now granted, I haven't actually introduced any lifetimes here, but I'm pretty sure that I'm not allowed to introduce lifetimes to this. Like, isn't this literally what I just did? I'd be kind of mad if it worked, actually. So I'm kind of glad that it did not work. Oh, found unit type. Oh, well, I'm not actually returning it. So fuck, it does work. What's the difference between what I just did, though? What's the difference? I think I get the difference. Okay, let's just think about this for a second. Okay, I think this is why it works. We'll see. We'll see if this makes any sense. Yeah, pointer read is the difference. So what happens is that pointer read essentially makes a bitwise copy, right? Without screwing up the original memory, right? And so pointer read makes a bitwise copy of that value. Technically, that's a brand, like that's a new value. I own it. I can do whatever the fuck I want with it, right? Like I can do other things with it. I can't mutate it, but I can use it as if I own it, right? Where if I'm dereffing it, the ownership model isn't broken at all, and there's no copy going on. So with pointer read, because of this bitwise copy, it can't figure out like how that lifetime's working. Yeah. Does that make sense to everybody? I think that's why it didn't work. So by not using pointer read, we're able to kind of like keep the ownership model in place. We still need the unsafe because add is still an unsafe operation, right? Pointer math, still unsafe. I could, of course, like put that in the unsafe block, but I don't bother. I don't want to have to say let p up here and then, you know, assign p here and then return it down there, right? We're just letting all this happen. Okay. Like unsafe doesn't get you out of the borrow checker, as we very well demonstrated. This is how I did it last time. I'm certain of it. And I remember being just as upset that and I didn't learn what I needed to learn back then, obviously. But that was 6 months ago, right? Maybe I'll actually remember this time. We'll find out. So with that in mind, we could actually just do this as a star p. We could just do star p here, which is nice. I'm pretty sure this will work. Nope, it doesn't work. Okay, so why doesn't this work? Cannot move out of a p, which, oh, right. Because we actually need the copy, right? Okay, this makes sense. So again, because vec owns this pointer, right? Yeah, unsafe means I know how memory works, yeah. So since the vec still owns this pointer, right, at the end of the day, a simple deref won't work. We need that bitwise copied in order to actually return an owned t. So we need pointer read here. Cool. Same lesson, different side of it. Okay, this looks good. And our test still passed. We didn't do anything new. So basically now, and this is what's cool. Okay, so if you don't know Rust that well, now that we implemented the index trait, one of the funnest parts about traits is now we can be really cool and say assert eq, if I can fucking type, assert eq L05, and this should work. It doesn't, but that's fine. All right, and it's because I don't actually need this asref trait bound anymore, so it's helping me out. I don't actually need that. Okay, let's try that test again. It still failed. Fuck. It's because I have an off by one error. It's because I did self.lin because I was copying my pop code. Oh my god, so dumb. All right, off by one. There we go. Anticlimactic, but there we go. Oh fuck, that was funny. Okay. So yeah, self.lin -1, obviously, and L0 is 5, and just for funsies, we can say assert eq. Assert eq, I can do this. L5 is 6. Yay. Okay, cool. So we actually wrote the code that I originally wanted to, which is all here. I'm trying to think if there's anything nicer to do here. This is probably the only code I'm going to put in the actual article. But we could keep going since that didn't take very long. I guess we might as well implement IndexMut because it's going to be almost identical. Oh, we could do prepend. Prepend is not the easiest thing in the world. But let's do IndexMut first. I think that probably... Yeah, prepend would be good because it illustrates this. I believe that's right. And let's see if this actually works this time. No, of course not. Why would you want it to work? Oh, I didn't even put it in. All right, so no wonder it's not working. In IndexMut. Okay. All right, IndexMut. Very good. Yes. And let's just look at the docs because I don't remember. Yeah, and there's a lot we can do. I think prepend would be really good, and we could do an iter implementation. Okay, that's right. You don't have an output for IndexMut. That makes sense because you're not getting anything on IndexMut. It's just allowing the mutation. Okay, that's why I'm getting an error. Let's see if this works. Let's see if Rust Analyzer knows what it's doing. Yay! We got something to work. Okay, IndexMut. So we have a mutable self, we have an index that's usize, and we need to mutate it, right? Let me see if I can remember how this works. No, it still wants an output. I'm a little confused. Does it not just grab that from the other IndexMut? Did you message me? Okay, I'm checking.
It's too late for the Trader Joe's stuff. It's for the packages, and they already went there.
I don't believe there are any packages. Let me look.
It says there is. It said it was delivered, so I don't know what they did then.
They must be. Oh, there is one. Just kidding. I guess I was like super not paying attention to messages. Okay. I sent them a package code. Okay. Where were we? The important question. Do you have an important question, Shandu? Do I exercise? Why? Why would you exercise? It is a very important question. Let's see. So I guess it just takes the type output. I guess the output is coming from the index implementation, and you have to implement index to implement IndexMut anyway. Okay, interesting. I kind of didn't remember that. Yeah, I mean, I do try to exercise. I stretch every morning or do yoga, and then I try to do walk every day outside, that sort of thing. That's my basic exercise plan. Okay, so side left, and then you just have to you just give it a mutable reference. You just give it a mutable reference. We can do this. It's going to be very similar to our other one. So again, if index is greater than or equal to self.len, we can say panic index out of bounds. And then we can say unsafe let p equals self.buff.pointer.as pointer. Now I really should have just added that little helper so I didn't have to type that every time. And this might actually work if we just say and mute star p, but we will need our lifetime annotations again. Looking good, looking good. I just try. Yeah, no, I just try. I can't say that I make it every single day. Good times. Okay, so before we pop all of this stuff off, we could mutate something, right? So let's just do here. No, that's too confusing. So after we've pushed all these elements, let's say we actually want element what, 3, so index 3 to equal something else. Index 2, I mean. So instead of 7 for index 2, we want that to be 25. That should work just fine. And then we say asserteq L2 is now 25. And before, this should have been 7, right? And then, of course, down here, we'd have to change this to 25 as well. Okay. Nice. I appreciate that this just happened to me. Okay, what did I do wrong? Left equals right failed. Left 6, right 7. Oh, no, that's wrong. What? How is that 6? On which one? Did I Oh my goodness. Oh, this is hilarious. Okay. This is hilarious. I can't believe I didn't check this. I was literally going to the last element every time. And the only reason the other test passed was because I happened to check the index of the last element in both cases. What an absolute fail. That's hilarious. Okay. Absolutely. Like I did too. I did first and last element, but the first element was the last at that point. So I thought I was doing pretty good. Fear My Gaze, what's up? Thanks for the follow. Oh my gosh. So dumb. So dumb. Okay, cool. So we got an index and an IndexMut. Looks pretty good. We now have this nice little easy assignment and get by index feature, right? Assign by index, get by index, etc. And as you can see, these are constant time because it's just pointer math. Pretty obvious, right? So what do we want to do? We could do prepend, which is annoying. We could impl iter. We could impl iter. What are we at? Hour 15? Yeah, I have time to impl iter. Okay, I haven't done this one in a while either. So let's see how we do. Impl t iterator for ArrayList t. And there's a few things that I need for this, and I don't remember them all. Come on, Emacs, you can do this. There we go. We need type item. Okay. And that should be T. Okay. And then we need next. Look at that speed of this computer. Okay. Which gives us the option self item. And I believe this is the only method that we actually have to implement. Okay. Let me think about this for a second. All right. Actually, what we have to do is get a vec iter. That's what we want to do. So we don't implement it for ArrayList. I'm remembering now. We implement it for we'll just be really cool and call it ArrayList iter t. And what do we say in our ArrayList iter t? We say that we have a vec, right? And then we have to have like a position. So let's just call pos usize. And then our actual data structure or vec, let's just do it as an into iter where it consumes, I guess, for now. I think that's what I've done here so far. Do I want to do consuming or do I want to do the way this works? I think then if I didn't want to do consuming, I'd have to say ref t, right? I think that's true. I'm forgetting. We'll just say pause and then we'll say list. Which is an ArrayList t. We'll do consuming first because it's easier. I don't have to think as much. And then you actually impl iter on ArrayList iter t. And then basically we'd have an into iter on our actual array list, and this is a mute self. Actually, it's not a mute self. It is self because it's consuming. Don't know how I went to that line, but that's okay. All right. And then we simply say ArrayList iter. And we say vec. No, what did I call it? List. List self. And pause 0. Okay. Let's see. So the iterator should work from the back. So essentially, oh yeah, so then I actually don't even need the pause. So I could do it this way, and then I don't even need the pause. And that's fine, because I'm not going to do a size or anything. And I think this will work. So then all I have to do is say self.list.pop. And it already does everything else for me. So let's see how this works. Yeah, okay. This should be pub. And all of that is fine. Okay, let's see that, make sure that it actually goes through. It does. We're happy. All that looks good. So instead of having these, let's just replace this with a iter test. So now we're going to say, actually what we could do is collect it into a vec, and that would be like a really easy test to make sure that it works all the way. So we could say assert eq vec. Let's see, this is going to be l.into iter.collect. I might have to give it a vec type and stuff. And then this is going to be vec of 10. Oh, it's going to reverse it when it iterates. I just realized. That's really funny. Is it going to do that? I think it might. I think it might. Let me think about it. Yeah, I could do a rev collect. We'll just see what happens. We'll just do it. We'll just do it my way, and then we'll see what happens. It will most likely not work. 25, 8, 9, 6. And so we use a vec macro there. I think it will reverse it, yeah. So then I'm thinking actually my iterator is kind of wrong. And the right way to do this would probably be to have a position and the vec, and then just read each memory pointer, right? Instead of doing this, because essentially I just implemented like a reverse iterator. It's fine. We'll see what happens. Yeah, so it wants some collect annotation. Let's just say it's a vec of, what are we, these U8s? Pretty sure this will fail. Nice. Perfectly backwards. Okay, so what's annoying is you actually have to implement reverse iterator. So I actually can't call rev on this. I'm like 99% sure. Yeah. So I actually already did my reverse iterator implementation. Double-ended iterator. That's what it is. Not bad. So I think actually the right way to do this would be to use pause. It's fine. So we'll start with pause 0. Let's see. Do we want to start with pause 0 or do we want to say pause -1? We'll figure that out. We'll figure that out later. Let's just impl ArrayList iter t. Let's just have a new, and then I don't have to pub function new. No, I don't want pub it. I just want function new. And it's going to take a list of ArrayList t and return self. Okay, looks good. And we'll pause 0 and list L. Well, actually, if we just call it list, we don't have to do that. Okay. Why don't you like me? What did I do wrong? I forgot all sorts of things. Okay. I hope you guys liked that song. Might help if I actually said the struct that I was constructing. Okay, so instead of self.list.pop, what do we actually have to do? We have to do pointer read, basically. That's what we have to do, is we have to pointer read. Which is fine. It's okay. We can deal with it. So let's just say unsafe. And let's see. Yeah, I think I do want -1 as my initial pause. I like this better. You can use the index and just increment the pause. I feel like I'm going to have ownership issues, though. Let me think about this. I feel like if I just use the index, I'm going to have ownership issues. We can try it. So if I say self pause, obviously this is going to fail on the first one. Oh, right. That's actually why I wanted it as at -1. Because then I'm going to say self.pause plus equals 1 here. And then this is just self.list pause. And this is a sum. I do have to put an index bound check on this. But I'm pretty sure that's not going to work, right? Because this is an anti. Yeah, I didn't write. Yeah. Oh, I did pause -1 and it's a U size. Classic me. I guess I can just make it an I size just for my own purposes. What did you do, Dylan? What did you do? That's cute. There we go. Very good. Okay, so we have this, and I don't think I can just deref it because again, oh, well, first of all, let's get the actual error and then we'll see what happens. Pretty sure it's going to tell me this is not the right type. Expected U size found I size. Yeah, that's fine. Oh, you can't do that though. Okay. I keep trying to make this easier on me and I'm just making it harder. So let's keep it at 0. I just wanted this to be smaller, you know? I wanted to increment the pause afterwards. I mean before, so then I could just have the return value and it'd be all done. You know? But no. It won't let me do that. Okay. So let's just say let n equals okay. Summon. Okay. I'm very surprised that it thinks this is a T. Cannot move out of index of blah, blah, blah. Yeah, so basically we're getting a move error, right? Because of issues, right? So what do we actually want to do here? I feel like probably the easiest thing is to just do a bitwise copy and use UNSAFE. Hey, Prophet, what's up? We did our really thin array list very quickly. But I had so much time that I decided to just start doing traits for it. Well, we got like a basic index and, you know, pop push new done pretty quick. Granted, it's also because we did the raw vec last week, right? So we didn't have to deal with the actual allocation logic. But yeah, it worked out pretty nicely. I don't think I can go anywhere here that it's not going to give me move errors. Even though I own everything, you know, I think no matter what, it's going to give me a move error on here without copying it, etc., etc. And that's why I pretty much just need to do the stud pointer thing. Now, the thing is this is where actually now I'm going back and saying this is actually easier if you do this. But all right. Oh fuck. I'm getting there. Just give me a second. I think I can do this. Like if we were not doing a consuming iterator, then you would be correct. Self.pause -1, just so I don't have to have an extra line of code. Where did in come from? Oh yeah, I had it in my other one. Self.list, self.pause -1. Okay, what do you hate? What do you hate about this now? Expected reference and found type parameter. What do you mean? Expected and T found T. Oh, because I can't do this, right? And I can't even do this, can I? No. Is it a different iterator trait? I'm forgetting right now. Oh well, let's go back to what we were actually doing to start with, and we'll go from there. Okay, so let n equals unsafe stud. I already have pointer in here. Pointer read. You know what? I'm really tired of this thing not being an actual method. So let's go ahead and make it a method maybe. We could do it on raw vec, but since we're here, we'll just do it on vec. Oh wait, I forgot. Oh shit. Okay. What did I do? It's just this line of code anyway. I had two things going on in my head at the same time. Okay, function, what do I want to say? Do I want to return that pointer as a raw pointer, or do I just want an offset function? I think I just want an offset function. Pointer at offset. I think that's kind of nice. We'll just do self offset is a use size. And then this is just going to return a star mute t. Oh, that's what it is. It's adding the lifetime. Yeah. Okay. Thanks, Prophet. I knew there was just something that was missing about it. Okay. Self.puff pointer as pointer dot add offset. If I could spell, we'd be even. I know. That's why I asked. I think I need, well, first of all, this is unsafe. So there's that. Is there anything else wrong with it? Nope, it's fine. Okay. And add, this all works. Okay. Apparently. Let's fix this now, which is our into iter is going to be ArrayList iter new self. Okay. That's better. This looks fine. Do we have any more? Okay, yeah. And that's because I just wanted to finally use this as self.list. I already forgot what it is. Is it pointer at offset? Nice. Pointer at offset, which is pause. Okay. But it's self.pause. Self.pause. Beautiful code. And then this is just sum in. Okay, there's a consuming iterator. That should work. She writes Java every day. That's her secret. Don't you know Java's bad? Aren't you on Twitter? Don't you realize that Java's bad? All right. Just kidding. It's a little partially inside joke for Prophet and I. Java bad. Okay. Yeah, new Java is pretty nice. Okay, so this should still fail. Wait, no, this one should work. I did a cargo test instead of just a cargo test array list. No, we're not doing that. Cargo test array list. What is it hanging on? What did I do? Oh no. That amount of hanging is not a good sign. I did increment self.pause. I have self.list.pointer and offset. Okay, what did I do? Oh no. Process didn't. Oh yeah, sig. Yes. Rust baby. That's hilarious. I did not. Oh, it's because I never did a out of bounds check. That's why. I never did a bounds check on this. That's so good. Okay. So if self.pause is equals self.list.len. I think that's right. Yeah, because we're incrementing it afterwards. Then we're going to return none. Else we have all this. Okay, let's see if it works. That's another nice part about collect. Yay! How nice that people on Twitter told me I should try functional programming. No way. That's so good, Alice. That's so good. I don't like else if you're returning from an if either. Why the else at that point? It's actually, yeah. So I hate early returns. It's just one of my weird things is I just hate early returns. Yeah. So I know all the normal people out there would just do return none and then they'd go on with their life. But I just hate it for some reason. I think it's just because I'm so used to languages that don't have them that I have a hard time making myself do an early return. I do kind of hate the order of this if though, so I might actually want to change it. Okay, I'm checking. Apparently there's a lot of important messages in the world. Okay. Should I tweet that I hate early returns? That would be really funny. Okay, let's just switch this around to where if self.pause is less than self.list.len, then we do all of this. Yeah, that would be a great take for Twitter just because people would hate me for it, but I don't necessarily do that on purpose. Okay, I like that a little bit better, even though I know some of you hate it. That's what it's for. Yeah. Oh, Alice, I read the little announcement thing on Juneling Monday. That was fun. Interesting ideas. Okay. Let's see. Oh yeah, right. So our consuming iter works. Now we should just do like a normal iter, and then we can just use index and just be like happy with our lives. I think that's a nice idea. How does the stdlib, what do they call it in Vec? I can't remember the types they use. I feel like they just have one that they call like consuming iter and one that's not, but I can't remember. Into iter. Sure. Impl to yay into Iterator for Vec. That's really funny. I actually did not impl the into Iterator trait. I just added it to my implementation. I forgot that this was a thing. I'm such a goober sometimes. I forgot that was a thing. I just put an intuiter method on my vec instead. I mean on my array list. All right, I guess we should fix that real quick while we're being so correct about everything. Sure, why not? Impl TA where A is allocator. Sure. No, usually it's that I forget that things exist. Shreyas. Yeah. I know there's no other window. I was trying to get a completion here. Not another window. Wow. Wow. It still was thinking about it, so we're just gonna type this out. For ArrayList T. Oh, the only reason there's an allocator, I forgot. The only reason they have an allocator variable is because vec takes an allocator. I don't have to do that. Okay, cool. And then we have into iter function into iter. Look at that. And what is into iterator from? Core iter traits. Not all trait items implemented. Missing type item, type into iter. Okay, okay, we're getting there. Okay, just chill for a second. Type item, type into iter. Oh, right. Okay, so this we can deal with. So type item equals t. Type into iter is ArrayList iter. Yeah, I did a colon instead of an equal. Okay, looks pretty good. Mega Chubs, fear my gaze. Not Pratham 1210. Thanks for the follow. I appreciate it. Let's see. I guess they want this, so I'm just gonna do ArrayList iter t, and that's fine. Self into iter. Yep, looks good. So then this is just my actual what I already did right here. It's not that hard. Yeah, we're scrolling, baby. We're using that scroll wheel. It's really good. Okay, so now let's delete my into iter that I randomly did on my own impl, but you know, that's fine. That's fine. And we'll run those tests again. Make sure everything's happy. Very good, very good. We're freaking pros. We've got into iterator. I think I just want to do our normal iterator, maybe. Let me think about this. Is that what I want to do? Probably. I don't know. What should we do? We got 14 minutes. We could do a normal iterator, but it's not like it's going to be that exciting. We could do prepend. Yeah, prepend is annoying as F. Okay. All right, sure. Pub function. We'll call it push front. I don't know if I can finish this in 15 minutes because I would probably be annoyed by it. Let's just yank all of this, even though it won't be quite that easy. But it'll give us something to start with. Just make a new one and copy the items. Yeah, we could. That would be nice. Unfortunately, if we were working with a immutable system, we could do things like that. But instead, we're just going to mem copy. Or mem move, technically, right? Std pointer copy. Okay. Let's see. So we're going to grow our buff to make sure that everything works fine. And now we have to give it a little pointer copy before we actually write to our original pointer. So first, let's do that. First, we're going to copy. I don't remember what pointer copy takes. It takes a const t, a dest t, a count, and a u size, right? And a count is just how many t's it's moving. Yeah. So this should work fine. We also, right, we created our little thing too. So we have pointer at offset now, right? So our source is actually just self.buff.pointer. Okay. It's actually easier. It's pretty bad, but it's easier to do pointer at offset 0 and self.pointer at offset 1 and self.len. Okay. And then where are we actually going to write? We're going to write at offset 0. And let's just get rid of this real quick. It's actually, now that we created that method, pointer at offset 0. I think this should work. We're about to find out. All right. Yeah, so we talked about that a little bit last time, but basically pointer copy is a overlapping copy. Source and destination may overlap. Otherwise, you can use copy non-overlapping so that you don't have the intermediate array. Yeah. And I believe, if I remember right, yeah, semantically equivalent to C's mem move. So it's mem copy that is the same as copy non-overlapping, and it's mem move that is the same as copy. Yeah, equivalent to C's mem copy. Rust docs, they're pretty fucking good. Okay. Self.pointer to offset 0. Let's just do a little push front onto something. Let's do it up here so we don't screw things up. How about that? L.push front 10. And this should be 1. And this should be 0. And this should be 10. And that's len 1. And that should be len 2. All right. I don't know if this is going to work. All right. It was probably just a me problem though, but we'll find out. Did I actually screw something else up? Left is 254 and right is 7. How? There's a really nice debug formatter function that I could do real quick, but I don't have time. And then we could see the whole thing printed out. That actually probably would have been the right thing. Push front changes all indices. Well, yeah, it would change all indices. But oh, wait a sec. No, this is fine. This is fine. I already know I have that pointer. Desta's mute pointer, ELTS, dest.setlen, ELTS. Yeah, okay. What did I do wrong here? So let's see. 161 was our panic. Let's just look at that real quick. L2 is 7. And this says L2 is... Oh, I never popped the other one off. Dumb. Dumb. Okay. Let's try that. Still failed. Okay. So that's interesting. The left is 5 and the right is 10. That tells me that it seems to have not it seems to have not actually written before the 5. But these are working. Let's just let me think. What do I want to do? What if we just say l.pop and don't assert and see which one of our tests are actually failing. Does anything else fail here? Nope. Okay. Oh, I'm just dumb. Oh my God. Oh my God. I did it again. Second time I've done that today. Oh, is he streaming? Okay, we could rate him. I just reversed it, obviously. Pop takes from the back. First try. My tests were my problem. As usual. All right. So, I mean, it's pretty cool, right? I mean, like, as a non-systems programmer in general, like, this is the kind of stuff that's scary, etc., etc. But at the end of the day, this is all pretty effing simple. Like, I mean, yeah, it requires understanding memory layouts and some of these other things, but like, it's not that hard, right? I mean, I can do it. Look at this. I don't have a CS degree. I can do this. You know, it's not so bad. No, well-typed wedge. No, we're not supposed to challenge me to do new things that I can't do. The thing is that I can actually do a mem move and I can write to memory and read from it and not have any obvious errors. That's how we're flexing these days. Yeah. Okay. We don't need this comment anymore. You don't think you could do a kinetic keep? Okay. Well, that says something, doesn't it? All right, cool. This looks good. Let's commit that up. ArrayList first try. All right. It's a lie. It's pretty close, though. It's pretty close. Bye, YouTube.